Welcome. This is a special mass flow edition of the Bill and Corey Show. This is
and you're who?
I'm Bill.
And I'm Corey.
In case you're new to the show. Why are we here today? Well, we're still locked out of our, not really locked out.
You can kind of look in.
We could go in the Icebox studio, but they're doing some work here and
some renovations, if you will.
Some renovations in Montgomeryville, so this is where we're stuck. We're stuck in the corner in the mass flow room. And what's behind us is, the reason why we're here is this big bad boy. This is a Bell Prover. And this is what we used to use a long time ago, not that long ago, to, for me it wasn't that long ago. This is what we used to calibrate our mass flow. And how it worked was, this is a big bell. It's like a big cylinder thing.
It's upside down, though, obviously.
Yeah, well, no, it's just a big thing, and it's in water to help make it buoyant. And then it's got counterweights, and you can't see that. I'll show that later. It's got counterweights. So what you do, this is our biggest one, and you have gas flow. So what you're doing is, it's got a little pointer there and the size, so you can see how much it rises up over time. And so this is a set volume. You know how much this is, and I don't know how much this is. It's big. So you're looking at flow rates. So you measure the distance it goes up over time, and then you've got your flow rate. You can calibrate stuff with that. And we use, seems kind of silly, but you can get calibrated stopwatches that are NIST traceable. Okay. So, but then they're only, we would replace them probably every 6 months or something like that for it. But we used to use these things. We've got another one over there. We can't show you that one.
A little bit smaller.
So that's what we used to use, the calibrate things. And things have kind of changed over the year for calibration stuff. We've got a variety of different standards. We've got some of the lower ones. These we get from, we don't make these. And these are NIST traceable, and we get them recalibrated. And then we've got our big bad boys. I forgot to bring that over. I'm going to have to go off screen. And we showed you this previously.
Where are you going?
I'm going over here.
Ah, yes. You need that part of it.
Yeah, this is the base. We talked about this before, and this is the latest and greatest. And these are super high accuracy. This
is the Bell Prover of today.
And it's funny. It is really like a Bell Prover, because some of this is like electronic. It looks at thermal conductivity, stuff like that. So fancy schmancy. So it goes complete circle. So what this does is it's got a little plug in there, float, and it measures. It's like that. It measures the volume and time. So it just goes up and down and up and up. It
usually goes up.
It goes up, and then it comes down, and then another shot goes up. So it does that a bunch of times to get it to measure your accuracy. So you're back to this, but an electronic version of this. So I better not break that thing. It takes like months to get calibrated.
That would probably cost a pretty penny.
Yeah.
Well, no, if you dropped it, it might break. You might buy a whole new one instead of get calibrated.
Yeah, oh jeez, I don't even think about that.
I know.
So we're gonna show mass flow stuff over here. You want to go?
Yeah.
Want to show some of the rotometer stuff?
Oh, here's a rotometer.
See, it's in a bag because this is an RMA and we fixed it up. So
where's the big? Like over there's a big.
I got a big one here. So this is kind of, we could have got.
That one's got one of the barbell floats in it, right?
Yeah, it's a barbell float. It tells you right here how to read it. Read the top kind of fat part of the float.
It's a lot more to lift the barbell, right? Than it does.
Yeah, it does. You have to work out a little bit.
So yeah, that's why it's a lot of flow.
Yeah, you're gonna see this a lot in gymnasiums, heavy duty labs. This is our workhorse, FM 1050. Yeah, we're in front of a live studio audience now. How about that? And this is This is our workhorse. It's got a millimeter scale. This was an RMA. Someone sent it back.
It's a reference scale.
A rep?
Isn't it?
No,
oh, it's not
a millimeter scale.
Okay, never mind.
Yeah, so they sent this back for some reason. I don't know what. Maybe for.
Maybe they didn't want it.
I don't know. No, we're sending it back. Maybe they need it cleaned or calibrated or something. I don't know. But that's why it's in a bag, all sealed up for your freshness. And this is one of our little plastic guys.
Acrylic.
Acrylic.
Which is a
100% acrylic. Well, it's plastic. It's kind of machining's really kind of difficult for this because it's hard when you're machining plastic. You have to be able to see through it and stuff. So this is kind of like the old school technology. Still works today. We got. What else we should? We've got things called secondary standards.
Oh. So
they get calibrated to the primary standard, which was that big bad boy, the Sierra Instruments ones. So this is so we use these if we're doing flow tests in house, like if we're testing a. Where'd you put the pin?
Right here.
Oh, okay. So using this if you're doing flow tests on something. So we might have a system we want to. Hey, what's the flow rate off of this? So we would use these to do our flow tests on. So these are calibrated by the Sierra, so it's really not, you can't really use that for official calibrations.
Yes.
But in-house, you just want to get a flow curve. You can use these. You've got different ranges on these. These are kind of old. This goes 50 liters a minute.
This one goes.
That's 30 liters a minute.
Yep.
So kind of tells you a bunch of stuff there. So as we're hopscotching around, this is part of it. We're still waiting for parts. So this is part of called a backup air system or backup nitrogen. It's a backup system. So it's a high flow one.
And this is pretty big. This is pretty big piping for us.
Yeah, it's pretty big. But you get a half inch. That's
yeah.
That's a.
Yeah, I don't think we ever go higher than a half inch. I haven't seen it.
Ball valve.
Yeah.
Just clamp down. So yeah, so this is a high flow. This would handle 15 cubic feet a minute. This is our 3200 series. It's acted as a dual stage regulator.
Mm-hmm. Oh yeah, I mean, dual stage regulator is two regulators in one essentially. So if you put two regulators next to each other, that's what they act like. Yeah,
the first one's set for I think 250 psi, and then this is down to I don't know 100 something like that.
And what do we use backup systems for? Maybe you could
for backup.
Backup to what?
It's well, if you have like let's say you got an air compressor.
Yes, there you go.
An air compressor. Running
stuff for shop.
Yeah, running your pneumatic backup.
Yeah.
And it breaks, it goes down for some reason. Someone unplugs it.
Power goes out.
It seizes, something like that, just has a bad day, doesn't want to do something. Well, if you got a system, if you got a plant running, you don't want to have everything shut down just because of that. So you have a backup system. So it'll run, so you have reserve cylinders there, run nitrogen, air for air. We've done hydrogen for hydrogen generators. So then it automatically kicks in. It's all pressure based. So let's say you're running your system, your compressor puts out 125 psi.
I was gonna go 130, but that's that's your
Okay, it could be 130, and then you go, well, you can't set this at 130 or it'll trickle through.
Yes.
So you figure, okay, what pressure do I really?
What's the minimum?
What's the minimum pressure? So let's say it's 100.
Yeah.
So you set this up for 100, and it starts flowing at 100.
At 100, whenever the 125 kicks out and it's not there anymore.
Or the 130 kicks out.
Or the 130.
Or 131. Whatever it takes.
Whatever it takes.
Okay.
And seamlessly we'll kick right on. And
okay, you want to put that back in?
Yeah.
So we're waiting for parts. That's why it's not done yet. What else we got to show you? Oh, really old stuff. Holy cow! So you got actually you want to get that box?
This one?
Yeah. This is a Fluke, and it's a really high accuracy voltmeter. So what you do is these things will put out like 0 to 5 millivolts typically. So if you can read the voltage, then you can take the voltage and let's say you're running a 5 liter a minute. and it's 0 to 5, so you can read the voltage. So if the voltage reads 5, that's 5 liters.
And this is going to read off of the
you hook it up to like the mass flow.
Yeah, the mass flow ones.
Yeah,
one of the electric ones.
Yeah, well, it doesn't work. You can't plug it into a rotometer.
No.
But yeah, you'd have this cabled up.
I just want to be. People might be thinking, how does voltage measure?
Yeah,
measure flow.
You're measuring you're measuring that. You can do 4 to 20, 0 to 5.
4 to 20 seems to be the milliamperes.
Yeah. Just so there's ways to take that signal and you convert it. So that's why you have a readout. It does the conversion for you. It does that math. So we take the voltage, then you can convert it.
Well, even this one has the voltage set VDC on it.
Oh, look at that. Yeah. 100%, 5, tells you different flow rates.
Tells you different flow rates for each of the set.
Pretty slick. Does a good job there. So that's that. So that's kind of, you want to put that away?
Yeah.
And then we've got a really old thing. And we're not quite sure how old this thing is. This actually, we had it sitting around for the longest time. Well, this is really old, but this is like it's a mass flow unit, and it can handle. It says 5.
It's got tubes in it, right? No, I don't know. No, it's got
no vacuum tubes in there. But this is an old way. So basically, what this is, it's a voltmeter. And this is a really old one, so I just saw it this morning, 8143. I don't know how old this is. It's got to be over 30 years old. So it's got 5 channels to select, so you can hook this up cable this up to your mass flow units. Yeah, well, that's just that's the output voltage coming out 0 to 5. Yep. You got this set up here.
Serial connection.
Yeah, you could plug in cable split to a whole bunch. You could have like 5 mass flow units, and then what you do is, obviously you have to plug that in, is you'd switch and say, oh, I wonder what's on channel, that's off. I wonder what's on channel, oh, that is on 2. So it's on 1, 2, 3, 4, and then you can read that, and that will convert.
It converts it, yep.
Yeah, and you can, I don't know how he does it, but I don't know if it's reading. Probably reading the voltage or something like that.
Now a lot of the mass flow meters we sell, all of them, they have a display screen, so so you don't have to.
So we got everything right there. You don't need this big box, and then.
So people still use them for remotely. It's because if you're not going to be right next to the mass flow meter.
Or for controlling, or whatever. For controlling, some people just like that, but this has it right there. If you're using this in an area where you can't read it, it's nice to have something remotely. Yeah, so this is all in here. You can do a lot of stuff with it. You
can connect a computer as well.
Yeah, you can do all sorts of neat stuff. And this is why I had to bring this one out. I always make fun of this. This is our little, it looks like a little Star Wars.
Yeah, it looks like a robot. It does.
Like a little robot guy with a display going up and down. This is our 8112. This is 8113. I don't know the difference, but it's 8112 series. It's a mass flow meter. You can't control the flow.
You just read it.
It's inexpensive. It was popular for a while, then we just couldn't. I don't think they made them anymore, the parts. So it has, only downside is it has plastic NPT fittings in and out.
Whoa.
So you have to be really careful tightening your fittings.
Oh, wow. You crack those real quick.
Yeah, I know.
Jeez.
So, but this is kind of popular, and like I said, you can't get it anymore. But you could, it was like an inexpensive line. it was kind of between rotometers and a full mass flow thing. It was one of these things. It does look kind of like a Wall-E or something like that.
I was thinking Star Wars more.
Yeah.
It's like an R2-D2 almost from the front.
Yeah. Yeah, he didn't have a face though.
No, he didn't.
Yeah, so I think we covered a lot of mass flow stuff.
Yeah. Anything you missed that you want? You didn't bring out that beast, that Brooks beast right there, that cylinder, the big cylinder thing?
Oh, this one?
That guy.
I thought, oh my God.
Oh man, I wanted to see you pick it up. That's why I wanted you to do it.
This is 200 liters a minute. Yeah. What was a high flow? Don't exceed 1,000 psi. I didn't know that. So yeah, this is a big bad boy mass flow controller. You can tell they have these little valves on.
1,000 psi is pretty good though for a mass flow controller.
Yeah. Roger's probably yell at me, you can't use it for that or something. So, yeah, I think we covered everything there. So that's it.
Yeah, we don't just regulate pressure. We can help out with flow.
Yeah, we do flow. We can trace it to NIST's calibrations and everything.
I just call it NIST. It sounds cooler. NIST.
It's like NIST. Okay.
Like mist.
These be Bureau standards. So that's all we got for this week. Tune in again next week for another episode of the Bill and Corey Show.
Set your VCRs.